Okay, okay. Let me tell you about the worst week of my career. I built this simple recommendation feature for a client's e commerce app, nested for loops comparing every user to every other user. It worked beautifully on my local machine with 50 test users. Then we launched. Real traffic hit 50,000 users. The server didn't crash, it just died. Slowly, painfully, like watching a Windows update at 2% for 6 hours. And here's the part that still haunts me. My code worked. It gave the correct answer. Nobody ever told me the answer was correct. They told me it took 4 minutes to load. That, my friend, is the day I learned that it works and it's engineered are two completely different sentences. So today, we're going to talk about a system that solved this exact problem at a scale so insane it makes my little disaster look like a kid's science fair project. We're cracking open the TikTok algorithm. And I promise you, by the end of this video, you're going to look at your own code differently. Now look, let's be real for a second. There's this belief floating around that algorithms and big O notation is just interview trivia.
I get it. I really do. You grind leet code, you get the job, and then you spend your first 6 months writing CRUD endpoints. Here's the harsh truth, though. TikTok isn't a social media app. It's a distributed real-time machine learning system processing billions of signals per day. Somebody, somewhere, sat down and asked, how do I rank content for a billion people without melting every data center on Earth? Think about Instagram or old school Facebook. Their entire engine runs on what we call a social graph. You are a node, your friends are nodes, content flows to you based on edges, meaning who you follow. 0 followers? Basically 0 visibility. It's a closed loop. Rich get richer. The influencer with 2 million followers posts a picture, it gets 200,000 views. You, with 12 followers, post the exact same photo? Nobody sees it. That's not a meritocracy. That's a popularity contest with extra steps. TikTok said, forget the social graph. We're building a content graph. The system doesn't care who you are, who you follow.
The only thing it cares about is, does the content itself match a behavioral pattern? This is why a kid with 0 followers filming in his bedroom can hit 10 million views overnight, while a verified account with 500,000 followers gets 200 views. Let me put this in an analogy. Imagine a massive library. The social graph model is like a librarian who only recommends books written by authors you already know. The content graph model is a librarian who has read every single page of every book, comparing the content itself against readers' actual behavior. That's not a social network anymore. That's a matching engine. Okay, so if it's not about followers, what is it comparing? This is where people get it completely wrong. Everyone assumes likes are king. Wrong. A like is a cheap signal. It costs almost 0 effort. The heavyweight signal is completion rate. Did you watch the whole video? And even more powerful than that, rewatch. Did you watch it again? A rewatch is a screaming, unambiguous signal that says, this content produced enough dopamine that I gave up more of my finite lifespan to consume it twice. You wouldn't weight every interaction equally. You'd build something like a weighted sum. If you scroll past a video in under half a second, that's a strongly negative signal, punished harder than a like is rewarded. This is genuinely elegant engineering. They built a regression model dressed up as an app. Same exact logic Netflix uses. Netflix tracks, did you finish the episode? Did you binge the entire season? Here's the underlying truth these companies figured out. Clicks lie. Time doesn't. Now here's the part that genuinely impressed me. A scoring function is useless without a distribution strategy. When you post a video, it goes into test pool 0, a tiny sample, maybe a couple hundred random users. Think of this exactly like a canary deployment in software engineering, rolling out a new feature to 1% of production traffic. If that tiny test pool produces strong signals, the video graduates. It gets pushed to a bigger pool. Metrics still strong? Bigger pool. Tens of thousands. Still holding? Millions.
This is exponential wave propagation, the same logic behind auto-scaling infrastructure. But here's the ruthless part. At any single stage, if completion rate drops below threshold, the algorithm pulls the plug immediately. You know what this reminds me of? A circuit breaker pattern. If a service starts failing, you cut it off immediately to protect the system. Think of a delivery company like FedEx testing a brand new shipping route. They send one truck first. If that route causes delays, they abandon it instantly, no matter how much they had already invested. That's wave propagation. TikTok is testing every video like a hypothesis, using completion rate as the p-value. Now, let's ground this in cold, hard numbers, because I promised you real stakes now, just theory. Imagine comparing every video against every user directly. With 1 billion users and 10 million videos, that is 10 quadrillion comparisons. This is exactly why they use approximate nearest neighbor search, turning an O of n squared nightmare into something closer to O of n log n. Fixing this bottleneck has cut AWS compute costs by 60 to 80%, saving companies hundreds of thousands of dollars a month. Remember Amazon's finding? Every 100 milliseconds of added latency cost them roughly 1% in sales. At Amazon scale, that 100 milliseconds is worth over $1 billion annually. 100 milliseconds. That's less time than it takes you to blink.
So when junior devs tell me the algorithm doesn't matter, I think about that number. 100 milliseconds. Billions of dollars. Let me get personal for a second, because I think this matters more than the math. There's a specific feeling when you write a brute force solution, like dragging a couch up 5 flights of stairs. Then there's the other feeling. You replace nested loops with a hash map lookup, and your function goes from grab a coffee to instant. That feeling isn't just relief.
That's genuinely one of the closest things to a dopamine hit you'll ever get from staring at a monitor. A lot of developers think elegant solutions are reserved for genius-tier engineers at FAANG companies. That's a lie you're telling yourself. Every optimized algorithm you'll ever admire started as somebody's ugly, brute force first draft. Now, I already know what some of you are thinking. I just build small internal dashboards. Why do I need to care? Fair question. You're right, you probably won't need wave propagation for a to-do app, but that's not really the point. The junior dev who writes an O of n squared query just for now is the same dev who gets paged at 3 a.m. when the startup grows to 100,000 users. Always ask what happens at 100x. That habit is free, and it'll save future you from a very bad night. All right, here's the big reveal. The thing that made my jaw actually drop when I first understood it. You'd think TikTok's algorithm's goal is to make your specific video go viral. It's not. The true optimization target is a single metric: total session time and return frequency. Your video going viral is just a side effect. You and your attention are the product being optimized.
A senior engineer asks, what is the actual system I'm optimizing for? 3 layers above this immediate task. That's the difference between someone who writes code and someone who architects systems. So here's what I want you to actually do. Not just nod along and close this tab. Pause for 10 seconds before writing a single line and ask yourself 3 questions. 1. What am I actually optimizing for here?
2. What does this look like at 100 times the current scale? 3. Am I weighting my signals by what's genuinely valuable? That's it. That's the entire mindset shift. You don't need TikTok's engineering budget to think like their engineers think. Stop just writing code that works. Start architecting systems that scale. I'll see you in the next one. Now go refactor something.